Hi everyone. In this video we will explore how to write a recursive lambda function in Excel. More importantly, we will see that how recursion works in general so that we can use it in any other programming language. We will break down the entire flow of a recursive process and walk through exactly how Excel executes each step. To illustrate this, we will use the classic example of generating Fibonacci numbers. So let's dive in. We will have two parts of this video. In the first part, we will see that how we can generate the nth Fibonacci number using recursion. In the second part, we will see that how we can generate the first 10 Fibonacci numbers. So let's proceed. First of all, let's see what are Fibonacci numbers and how do we generate them. We are given with the first two Fibonacci numbers. The first Fibonacci number is 0. The second Fibonacci number is 1. How do we get the third Fibonacci number? We get that using the sum of the first Fibonacci number and the second Fibonacci number, which is 1. To get the fourth Fibonacci number, we will need the sum of the second Fibonacci number and the third Fibonacci number. We have 2 here. Now, if we drag this down, we will get n Fibonacci numbers. So, let's say ninth Fibonacci number is 21 and first 9 Fibonacci numbers are these numbers. Okay. Now, let's see that how we can use recursive lambda to generate nth Fibonacci number. Let's go to the working sheet and let's set up the complete flow here. So let's say we need fifth Fibonacci number. So for that, let's say n equals to 5. Now we saw that to get the fifth Fibonacci number, we will need the fourth Fibonacci number and the third Fibonacci number. So to get the fifth Fibonacci number, we will need again two numbers, which is fourth Fibonacci number and the third Fibonacci number. If we have to generalize this, what is 4? It is basically n minus 1. What is 3? It is basically n minus 2. Now to get the fourth Fibonacci number, we have to get the third Fibonacci number and the second Fibonacci number. To get the third Fibonacci number, we have to get the second Fibonacci number and the first Fibonacci number. So for 4, we will need the third Fibonacci number and the second Fibonacci number. For third Fibonacci number, we will need second Fibonacci number and the first Fibonacci number. To generalize this again, this is n minus 1 and this is n minus 2. This is again n minus 1 and this is n minus 2. N in this case is 3, right? And n in this case is 4. To get the third Fibonacci number, again, we have to break this down. We need the second Fibonacci number and the first Fibonacci number. Now let's see if we need the further breakdown or not. So if we see, do we have the first Fibonacci number? Yes, we have that. Do we have the second Fibonacci number? Yes, we have that. So we will stop here. We have this as well, so we will stop here. We have this as well, so we will stop. We have this as well, so we will stop. What is the first Fibonacci number? It is 0. What is the second Fibonacci number? It is 1. It is 1. It is 0. It is 1. Here is the important point. What is the third Fibonacci number? What is the third Fibonacci number? It is the sum of the second and the first Fibonacci number. So we have to add these two, right? We have to add these two numbers in order to get the third Fibonacci number. If we add these two, the third Fibonacci number will be 1. Likewise, if we see, now we have the third Fibonacci number and the second Fibonacci number here, right? If we add these two, what we will get? We will get fourth Fibonacci number, which will be 1 plus 1, which is 2. Now similarly, here as well, if we see the third Fibonacci number, it is the sum of these two, sum of these two, sum of these two, right? If we see the third Fibonacci number, it is the sum of second and the first Fibonacci number, which will be 1. Now we have to again apply this function here, sum function here. We have to add the fourth and the third Fibonacci number to get the fifth Fibonacci number, which will be 3. And if we see, the fifth Fibonacci number is 3 here. So this is how recursion works. In simplest definition, if we try to define recursion, recursion is nothing but a function calling itself. Or we can say that we are trying to solve sub-problems after dividing a problem into further sub-problems. So the problem was that we have to get the fifth Fibonacci number. We divided that into further sub-problems. Sub-problems were that we have to find out the fourth Fibonacci number and the third Fibonacci number. We again did the breakdown until we reach the base condition. So this is the base condition and this is the base condition as well. Here the base condition is satisfied. We know the results here. So we will again go back up, applying our function, and we will then get back the final result, which is this one. Okay, which is this one. Now, how does this actually work and how we can write the recursive lambda? Let's see. So let's say we name our function as FIB, right? FIB function to get the nth Fibonacci number. Let's say the input for this is 5. Now again, to define FIB function, we can say that FIB function gives us the nth Fibonacci number. So if we input 5 here, we will get the fifth Fibonacci number. Okay. Now to get the fifth Fibonacci number, we will need fourth and the third Fibonacci number. So we have to further break this down. We will again apply FIB function on 4, which is again FIB function on 3, which is again we have to define n minus 2 and this is n minus 1, right? If we again break this down further, we will need the third and the second Fibonacci number. So this will be, and again this will be 3 and 2. This will be 2 and 1. Here the base condition is satisfied. Here the base condition is satisfied. Here the base condition is satisfied. So we will return 1 here, 1 here, and 0 here. Likewise, we will break this down further. We will use FIB function to get the second Fibonacci number and the first Fibonacci number. Second and the first Fibonacci number. The base condition is satisfied here. And we have the result as 1 and 0. What is the function that we have to apply? We have to add these numbers. So we will add them. We will add these two. We will add these two. We will add these two, and we will get the final result. If we add these two, what will be the result of this function now? It will be 1. What will be the result of this function? It is given to us, right? 1. Again, 1 is given here and 0 is given here. Now for executing this function, we have the results, right? This will return 1 plus 1, that is 2, and this will return 1 plus 0, that is 1. Now 2 plus 1 will be 3. So this is how we will define our function. We will keep on changing n at each step until we reach the base condition, And once the base condition is satisfied, we will get the result, we will apply the function, go back up and get the final result, right? So let's go and let's write down the lambda function for this. There are two ways to write the lambda function, actually three ways. So one of the ways is to go to formulas tab and the name manager and define our lambda. Second way is that we can use let function here in this cell and define our lambda function directly here. The best way to define the lambda function is by going to Excel labs, and here we will have advanced formula environment in which we can define our functions. Okay, so let's define our functions. Let's go to modules. We can also define our function in the formulas or in the functions tab as well, but we will go to modules and we will define our function here. So let's say we name our function as FIB. Again, what is the definition of FIB? It is that it returns the nth Fibonacci number. So nth Fibonacci number is the definition of FIB function. For defining a recursive lambda function, we will need the lambda function here, and the input here will be n. That is the nth Fibonacci number. Now we have to further define our conditions. So first of all, we have to define the base conditions. That if n is equal to 1, then we need 0 because 0 is the first Fibonacci number. Else if n is equal to 2, then we need 1 because 1 is the second Fibonacci number. Else what do we need to do? Let's say if n is 5. If n is 5, then what do we need? We need fourth Fibonacci number, which is, again we will call FIB function, which is n minus 1, and to this we have to add the third Fibonacci number, which will be n minus 2. Okay. Now again 1 will be subtracted from n. In the next step, what will happen? N will become 3, right? If we started with n equals to 5, it became n equals to 4. In the next step, it will become n equals to 3 because 1 is subtracted at each step. If we see here as well, this is what we have done, right? This is what we have done. At each step, we are subtracting 1 from n. In the first branch, in the second branch, we are subtracting 2 from n. So this is how we define our lambda function, recursive lambda function. Let's save this and let's get the advanced formula environment here. Let's go to this sheet and let's use the FIB function. So let's say we try to find out the 7th Fibonacci number. So for that we will use equals to FIB, and let's say we input 7 here, press enter, and we have got 8 here. Okay, we have got 8 here. Now we can further shorten this function. So what are we trying to say here? That if n equals to 1, then we want 0. If n equals to 2, then we want 1. If we have to shorten this condition, we can say that if n is less than equal to 2, then we want n minus 1. So if let's say n is 2, then we will get 1. If n is 1, then we will get 0. Okay, so let's save this. Okay, we have this one bracket extra here, so we have to remove that. And now if we save this, you can see that we have the same result here. If we let's say change this to 10, we have 34 here. If we change this to 15, we have 377 here, which is the same result that we have here as well. So this is how, using recursion, we can find out the nth Fibonacci number. Now let's see how do we find first n Fibonacci numbers. So let's say we need first 5 Fibonacci numbers. So n is equal to 5, and we know that the initial Fibonacci numbers, the first two Fibonacci numbers are 0 and 1. So we can have another parameter here named as, let's say, initial equals to 0 and 1. Now, in order to get the first three Fibonacci numbers, what do we need? We need the first two Fibonacci numbers, right? Appended with the sum of last two numbers from the previous sequence. So what do we mean by that? If we go down and let's say we need the first three Fibonacci numbers, what we will have, again we need, our goal is to generate first five Fibonacci numbers. In it will become 0, 1, appended with the sum of last two numbers from the previous sequence. That will be 1 again. Okay. Now again, if we see how many numbers have we covered until now? We have covered three numbers. Here we covered two numbers. Now, are these three numbers equal to 5? No. So we will proceed further. We will go down and we will again have n equals to 5 because we are intact there that we need 5 Fibonacci numbers. First 5 Fibonacci numbers. We will update the second parameter here, that is init, and that will now become the previous sequence, the previous value of init variable appended with the sum of last two numbers, which are these two numbers. So that will become 2 here. And now, how many rows are there? How many rows are there in this? 4. So still the condition is not satisfied. 4 is not equal to 5. We will go down further. Okay. And now, n will be 5 and init will be 0, 1, 1, 2, the previous sequence, and appended with the sum of last two numbers, that is 3 here. If we see the number of rows that we have in this is equal to 5, which is satisfied now, and hence what we will do, we will return this. We will return this. Okay. So this is what we have to do. Now let's define our lambda function. So let's go to Excel Labs, and here let's define the function. So let's say we name our function as FIB underscore series equals to lambda. What are the inputs that we will need? We will need n, that how many numbers do we have to generate, how many first Fibonacci numbers we have to generate, and we have to get the initial Fibonacci numbers. So we will have this parameter as well. Now, if the rows in init are equal to n, if rows are equal to n, then what do we want? We want init back. Else, what do we want? We want to call back Fibonacci series function. Again, let's focus on the definition of FIB series function. What does it do? It takes an initial array and grows it until a condition is satisfied, right? So n will be same, right? N will be same, and to the previous result, to the previous series, right? Let's say if we want first 5 Fibonacci numbers, then what do we need? We need the first 4 Fibonacci numbers, right? We need the first 4 Fibonacci numbers, and to that we have to stack the sum of last two numbers. Okay, so that will become, we stack the previous result, previous init that we have, to that we have to stack the sum of last two numbers. So for last two we will use take function, last two numbers from the init again, comma -2. This is our function, right? So let's save this and let's have this here, and now let's call our function. So equals to FIB series, let's say we want the first 10 Fibonacci numbers, and we are starting with this here, right? We are starting with 0 and 1, right? Close the bracket, press enter, and we have the first 10 Fibonacci numbers. If we want first 15, then we will have first 15 numbers as well. Okay, we can go on and grow this. Edge case is, let's say if we input 1 here, then we are getting this num error, right? Because rows in it will never be equal to 0, be equal to 2, right? Because number of rows are how many here? 2 here, and we are having 1 here. So the number of rows here will never be equal to 1. So we are getting num error here, right? It will go into infinite loop. It will go into infinite loop because the rows in the init variable that we defined here, that is 0 and 1, we have 2 rows here that will never be equal to n here, which is 1. So it will go into infinite loop. And if we, let's say, input 2 here, then we are getting 0 and 1 here. So we have to add one more condition here, that if n equal to 1, then we want 0, else we want to carry out this. So let's close another bracket here and let's save this. And if we now see, if we, let's say, try 1 here, we are getting 0. And if we input, let's say, 3 here, we will get the first 3 Fibonacci numbers. If we input, let's say, 13 here, we will get the first 13 Fibonacci numbers. So this is how we use recursion in Excel. We saw that how we can generate nth Fibonacci number and how we can generate first n Fibonacci numbers. We also saw that how we can define our base condition and what happens if the base condition is satisfied. So that's it for this video. I hope you like this video. Stay tuned for more such videos on recursion and other topics. If you have any suggestions, please comment down, and please also comment your feedback on this video. Thank you and hope to see you soon in the next video.